Hello, my name is Matthew Pace. In the first video in the series, we saw how we could go about setting up an abstraction shape and finite element model for a simple design geometry. In this video, you're going to see how to actually set up the loads, boundary conditions, run the analysis, get results, and then do a simulation-driven design iteration. So, to create the simulation, we're going to go to the compass and choose mechanical scenario creation. This is one of several different applications that you may use to define loads and boundary conditions and perform an analysis. So we're now asked to select the type of analysis we're going to perform. It'll be structural. We're going to associate that analysis with a particular finite element model. In this case, we only have a single finite element representation, but we could have multiple. These could be different types of representations in terms of shell versus solid mesh, different levels of fidelity in our mesh, things of that sort. So now that we have associated our finite element model, we're going to go ahead and create a step. We're just going to create a general static step here. And we're going to fix one particular region in our model. And this back face, we're going to use a propagate by angle approach to make sure we select all our surfaces. We're going to go ahead and say OK. We're going to apply a shell edge load on the other end of our geometry. And we're just going to pick two edges to apply that shell edge load. And here we're just going to kind of guess them probably 5,000 kilograms per second squared. We'll go ahead and say OK. And at this point, we're ready to go ahead and perform our simulation. I'm going to move over to Simulate in the action bar and run the analysis. Once it's completed, we'll come back and look at some results. Welcome back. Now that our simulation is completed, we have some results. Right now, we're looking at von Mises stress. You can also look at other things such as displacement, and of course, do things such as animating the deformed shape. So now that we've had a particular response from our design, what we may be interested in is making a design change and seeing how that has a positive or negative effect on the overall performance of our design. So at this point, we're going to go back to our first tab where we have our model open. I'm going to hide our abstraction and finite element model and just show the design shape. So within our design shape, there were some parameters that were already defined that allow us to quickly and efficiently make changes to our model. I'm going to choose a particular parameter, the stiffener offset, and change it from about 100 millimeters to 150 millimeters. When I say OK, you're going to see that the geometry updates to reflect this new parameter value. So what happens to all of our associated data? So I'm going to go ahead and show the abstraction shape, and you'll see that right now it reflects the old state of the design and not the new state. You can see this also in the tree with a little red thumbs down on that abstraction shape. So we can go ahead and just do an update on our whole part. And what you'll see is now the changes from the design will propagate through to the abstraction and the finite element model. This is really what it means to me to be model-based. You see the abstraction updated itself. Correspondingly, the mesh has also updated. One thing that I would note is that the mesh is updated, retaining the approach of removing the holes from the mesh, having a ring around the large hole. So all those specifications have been reapplied automatically to the new design shape. If we go back to our actual simulation, we have some results. If we go to our tree, you'll see that our scenario, we do have now a little red thumbs down on our scenario as well as our results because we have had a design change. In order to generate some new results to assess this design, it's really as simple as moving back to scenario and re-executing the simulation. The one change that we'll make from before is instead of overriding the previous results, we'll choose to keep the previous results, allowing us to do a comparison from the previous design iteration to the current. Welcome back. We now have results for our new design iteration. What we can do is very easily compare results between our previous and current. We may be interested in things such as displacement or von Mises stress. So what you see on the right of the screen are a previous design iteration with the corresponding displacement of von Mises stress values. On the left, you see the newest iteration. Doing side-by-side comparisons can help us to easily understand which of our design alternatives may be ideal to progress to an additional stage of design.